Hi students, welcome back to our channel Smarter Everyday Over Learning. Dear students, we have been learning classes from the chapter Organic Chemistry, some basic principles and techniques from grade 11 NCERT. Right, dear students, in our previous session about qualitative analysis completely completed. Okay, now in this session we are going to start the topic of quantitative analysis in this detection of carbon and hydrogen. Right, okay, and previous details and everything I'll provide for you in the description. You can go through them. In qualitative analysis, what are the elements present in that particular organic compound that we discussed, and now in the quantitative analysis, in how much amount of substances of the elements present in that specific organic compound. Let's see in this quantitative analysis. After detecting the various elements present in a compound, in the next step we have to determine the percentage of each element. This is only called as the quantitative analysis. We shall now discuss the principles involved in the estimation nothing but quantitative analysis of various elements usually present in the specific organic compound. Estimation of carbon and hydrogen. A known mass of the organic compound. If you know the mass of the taken organic compound, this is known mass of the organic compound, is heated strongly with excess of dry copper oxide. Here, excess of dry copper oxide in a current of dry air or oxygen free from carbon dioxide. Okay, oxygen free from carbon dioxide. Under the specific conditions, carbon present in the organic compound is oxidized to carbon dioxide. Okay, let's see the equation for this. If you take the carbon, the organic compound of carbon, and if you add excess amount of copper oxide to that substance, then if you heat gently, then this carbon is oxidizes into here CO2. Then Cu can be separated. And students, if you take for suppose of hydrogen here also same from organic compound, to this if you add just like this copper oxide, then heat gently. Here also same this hydrogen is oxidizes into H2O. Then here also same Cu can be separated. Here the H2O, then if you balance this equation, here if you place 2, it will be balanced. Okay, here you have the important apparatus for estimation of carbon and hydrogen. Here students, you can see the pure dry oxygen inlet. Through this small narrow tube you have to add pure and dry oxygen. Here is the Bunsen burner, or instead of this you can take any spirit lamp also, no problem. Here is the Bunsen burner and sample in platinum boat. Here is the boat shaped structure. This is called as platinum boat. In this platinum boat you have to take the sample. Which sample you have to you want to test the sample that you have to take in this platinum boat. And here in this place of this furnace narrow tube, CuO, copper oxide, you have to take for just for the oxidation method. Here is the CuO. Okay, and this is known as furnace and combustion tube. When the entire heating processes takes place, that is only called as combustion tube. So here in this combustion tube, complete heating processes takes place. Okay, here U-shaped 2 tubes are located. Okay, and here one outlet also is there, outlet. So through this outlet excess amount of oxygen will go out. Okay, through this outlet. Right, in this first U-shaped tube you have to take the anhydrous calcium chloride or MgClO4 twice, magnesium perchlorate. So anhydrous calcium chloride, what is the use of this? Means it can If any presence of moisture is there in the substance, then this anhydrous calcium chloride will absorb that complete moisture from the substance. Okay, here if you take magnesium perchlorate also, this is the same function of calcium chloride is shown by the magnesium perchlorate also. And here you have the second U-shaped tube containing KOH solution. KOH nothing but potassium hydroxide solution. And students, if you take in the place of KOH solution ascarite also, ascarite nothing but here you can see a combination of NaOH and CaO, calcium hydroxide. Okay, then these two solutions function is same, KOH function and NaOH plus CaO, these two substances function also same here. Then KOH solution, and students, excess amount of oxygen, it is the outlet. Then in this substance completely, if there is a presence of excess amount of oxygen, it will be go out from this outlet. So this is the diagrammatic representation of apparatus to estimate the carbon and hydrogen. Now let's see what is the animated part of this activity, how the working of this complete apparatus. Let's see in this activity. In this quantitative analysis, the apparatus used for estimation of carbon and hydrogen. Here you can see at the starting a tube-like structure, and here is the Bunsen burner. And students, here you have to take the sample in platinum boat, and this completely connected to a furnace, and furnace containing copper oxide, and here U-shaped tube which is containing anhydrous calcium chloride, or you can take here magnesium perchlorate also. Okay, here is the first U-shaped tube. Now here is the second U-shaped tube which is containing KOH, potassium hydroxide. Okay, or in case of here ascarite or NaOH plus CaO combination. Ascarite nothing but sodium hydroxide and calcium oxide combination. You have to take these solutions. Okay students, this is about the complete information of apparatus for estimation of carbon and hydrogen. Here you can see the calculations from the masses of carbon dioxide, from the masses of CO2 and water formed. The percentage of the carbon and hydrogen can be easily calculated. Now let's see the calculations of this. For suppose the mass of the substance is taken as, mass of the substance is W, small w grams, and students, the mass of CO2 formed, that should be X grams. This is mass of CO2. And now mass of H2O, mass of water is formed, that should be, you have taken as Y grams. Now the percentage of carbon, 1 mole of CO2 contains 1 gram atom of carbon, that indicates carbon. Carbon atomic mass is 12 plus here 2 oxygen atoms are present, 2 into oxygen atomic number 8, then the mass should be 16, 2 into 16. Okay, this is 44 grams of CO2. Then 44 grams of CO2 contain the carbon amount is 12 grams. So here 12 grams represents that amount of carbon. Now therefore X grams of CO2 will contain carbon is equal to 12 by 44 into X grams. Basing upon this, you need to find out the CO2 containing carbon. This is the mass of the carbon percent in W grams of the compound. Now the percentage of carbon in the specific compound can be calculated by this formula, 12 by 44 into X into 100 by W grams. Right, that is the percentage of carbon, we can say that 12 by 44 into mass of CO2 can be formed, which can be mass of CO2 formed by mass of the taken substance, mass of the substance has taken into 100. Okay, this is the formula of percentage of carbon. Okay, 12 by 44 into mass of the CO2 can be formed by mass of the substance we have taken and into 100. This is about the complete calculation of percentage of carbon basing upon its molecular mass 12 and 24. This is the formula. Now let's see the percentage of hydrogen. Like this only, the percentage of hydrogen. Okay, you know very well, 1 mole of H2O, 1 mole of H2O contains 2 grams of atoms of hydrogen. Why? Because H2O, right? Then 2 grams of atoms of hydrogen. That should be, that indicates that 2 into 1. Why? Because 2 atoms of hydrogen. Here hydrogen 1 is the atomic mass of hydrogen, plus here O means oxygen atomic number 8 and mass is 16, right? And we should get 18 grams of H2O. Contain hydrogen is 2 grams. Okay, then therefore Y grams of H2O contain hydrogen is equal to 2 by 18. 2 by 18 into Y grams. Okay, students, here, and this is the mass of the hydrogen percent in W grams of the compound. Now the percentage of hydrogen in the compound is known as 2 by 18 into Y into 100 by W. According to this previous one, we can derive the final formula like this. The percentage of hydrogen in the specific compound is 2 by 18 into mass of H2O is formed by mass of the total substance we have taken into 100, according to this. Okay, right. Here students, in this case some modifications under the specific conditions are there. Let's see what are they. Substances containing nitrogen under the conditions of combustion. The conditions of combustion, if the substance containing nitrogen, if present in the organic compound, is oxidized to oxides of nitrogen. Oxides of nitrogen, those are NO and NO2, which are also absorbed in KOH solution. These two are absorbed in KOH solution. In such cases, a reduced copper gas is present, is placed near the exit end of the tube, already shown in the figure, which can be reduces oxides of nitrogen back to N2 gas. That should be, for suppose Cu plus NO. Then apply some heat to this CuO and N2. This is the equation, net equation for this. And if you want to balance this, here N2 is there, then if you place before NO 2, here also 2 CuO. Okay, then here Cu is oxidizes as CuO, and here NO is reduces into N2, right? And Cu plus NO2, CuO plus N2. And for suppose if you balance this, here if you place 2, here 4, here 4, Okay, here also same thing you are going to observe here. Cu is oxidizes into CuO, and this NO2 is reduces into N2. Okay, this is the way of explanation. If for suppose in that particular organic compound nitrogen is present, then in that tube, already I shown you that apparatus of estimation of carbon and hydrogen. Okay, in that tube, if you do these two reactions, right, and for suppose substances containing halogens, for suppose halogens present in the specific organic compound, these are converted into cupric halides, okay, which themselves decompose to form free halogens, These halogens are volatile cupric halides, also get dissolved in KOH solution, what we have taken in that U-shaped tube, KOH solution. In such cases, a roll of bright silver gauze is placed near the exit end of the combustion tube. Then silver gauze decomposes volatile cupric halides, forming non-volatile silver halides. Let's see the equations for this. CuX2 plus 2Ag gives rise to 2AgX plus Cu. Okay, X, in the place of X you can place chlorine, fluorine, bromine, iodine. Okay, these are the halogens, and X2 plus 2AgX, these are the halogens. Substances containing halogens, if you do like this type of process, you can easily extract them. The substances containing sulfur or sulfur halogens. Under the conditions of combustion, sulfur, if present in the organic compound, is oxidized into SO2, which will also be absorbed in KOH solution, what we have taken in U-shaped tube. In such cases, either an additional layer of fused lead chromate, nothing but PbCrO4, lead chromate, is placed after the Cu. At high temperatures, this lead chromate is decomposed into PbO and Cr2O3 and O2. This lead chromate decomposes to give oxygen, which oxidizes carbon and hydrogen of the organic compound to produce CO2 and H2O respectively. And here, if you balance this equation, if you place here 4 and here also 4 and here 2, here 3. Okay, this is the balanced equation. And here, students, SO2 and some halogens produced during combustion reaction with lead chromate to form non-volatile lead sulfate and lead halides also. When lead chromate is reacts with SO2, then this is the equation, net reaction. Now let's balance this, and if you place here 4 and 4 Pb, then here also 4 and Cr2O3, here 2. Okay, now equation is balanced. Now the lead chromate reacts with halogens, then the equation should be PbX2 and Cr2O3 plus O2. Now let's balance this. 4 PbX2 like this, and here also 4 and here 2 coming to oxygens. If you place here 5, then all the same number of atoms should come, both sides, reactant side and the product side. Okay, besides sulfur and halogens, PbCrO4 is also useful for phosphorus containing compounds also. This is because oxides of phosphorus produced during combustion also react with lead chromate to form non-volatile lead phosphate. Let's see the equation for this also. For suppose PbCrO4 is reacting with P2O5. If in that organic compound phosphate element is present, then heat gently. Then students, Pb3 PO4 twice lead phosphate, including with this again Cr2O3 plus O2, same. This is the total net reaction, and now we should balance this. First we should balance lead elements. 12, here 4, and here also 4, here 6, and here 9. If I place like this, now the equation is balanced here. This is for, suppose in that substances presence of phosphorus is there, this is applicable. Now let's see just one example. On complete combustion, 0.246 grams of an organic compound gave us 0.198 grams of carbon dioxide and 0.1014 grams of water. Determine the percentage composition of carbon and hydrogen in the compound. Okay, this is the question. Here some amounts they have given in the specific organic compound, and we have to determine the percentage of composition of carbon and hydrogen. Here the mass of the organic substance taken, that is 0.246 grams. This is the mass of the organic compound what they have given. Okay, now mass of CO2 is formed. Mass of CO2 is formed, that is 0.198 grams they have given. And such a way mass of H2O is formed is 0.1014 grams. Now students, this is the complete information. Basing upon this, you need to calculate the percentage of carbon. Now the percentage of carbon you need to find out. Okay, now 1 mole of CO2 contains 1 gram atom of carbon. Okay, that is already we have done. 44 grams of CO2 contains 12 grams of carbon. Okay, therefore 0.4950 grams of CO2 means 12 by 44 into 0.198 grams. This is the mass of the carbon present in 0.246 grams of the compound. Okay, now the percentage of carbon present in the compound should be, we can calculate that 12 by 44 into same 0.198 grams into 100 by, that is weight W grams, that is 0.246 is equal to, if you simplify this, you should get here 21.98. So this is the percentage of carbon. Now let's see the percentage of hydrogen. Basing upon this only, according to 1 mole of H2O, for suppose 1 mole of H2O contains 2 grams of atoms of hydrogen. That indicates 18 grams of H2O contains 2 grams of hydrogen atoms, and 0.1014 grams of H2O will contain hydrogen should be 2 by 18 into 0.1014. This is the mass of the hydrogen present in how many grams, students? 0.2475 grams of the compound. Right. Now the percentage of hydrogen in the specific compound, the percentage of hydrogen is equal to 2 by 18 into 0.1014 into 100 by, that is gram W, 0.246. Okay, If you simplify this, you can get the answer as 4.58. So this is the answer. Okay students, this is the complete information about how we can calculate in a complete combustion reaction. They have given the weights of the substances. Then we need to calculate the mass of the carbon and the mass of the hydrogen. Okay students, this is about our today's session completely on quantitative analysis, detection of carbon and hydrogen, and about this apparatus for estimation of carbon and hydrogen also I explained to you. Okay students, what is your opinion? And if you understand this class, just your views and your doubts also convey in the comment section. If you like this class, please subscribe and click the bell icon for my further updates. Thanks for watching.